In this video we're going to go through some worked examples of differentiation. So I suggest, in order to get the best out of the video, that you pause it and you give the examples a go yourself first of all before you watch my worked solution. Okay, so let's get started. So let's say we had the function f of x is equal to 5, and we were looking to find f derivative of x. Well, we know that f of x equals 5. That's the same as saying f of x equals 5 times 1. But it's times 1 to the power of 0. So 1 to the power of 0 is equal to a value of 1. In fact, anything raised to the power of 0 is defined as a value of 1. So therefore we could say here that f derivative of x is going to equal, well, that would be 5, but it would be multiplied by the 0, so you would take the 0 down, so it would be 0 times the 1, and then it would be to the power of minus 1. But if you multiply 0 by anything, you're just going to get a value of 0. So whenever we differentiate a constant, we get a value of 0. So we could write it out generally. We could say f of x equals c, and say c is a constant. Then we can say f derivative of x equals 0. So that's what we would term an analytic way of looking at that problem. But we already know the solution to this in a graphical format, don't we? Because if we were to draw out this function here, f of x equals 5, well, there's x, there's f of x. Now 5 is just a line that runs along at height 5, and we know when we're differentiating, we're looking to find the rate of change of this line. Well, this line's got constant gradient, and the constant gradient is a gradient of 0. So the gradient of that is 0, so whenever we differentiate that 5, we just get the gradient which is equal to 0. So it's obvious that that's going to be f derived of x is equal to 0. You wouldn't need to write all this out. So the next time you see a constant, you know that when you differentiate the constant, you get 0. So let's look at the next one. So let's look at this example here. F of x equals 2 upon 3 root x minus 5 upon the cubed root of x to the power of 5. So we want this in a format we can use, so we can rewrite that as 2 upon 3. Now the root of x is the same as x to the power of a half. And the second line is minus 5 upon, now the cubed root of x to the power of 5 is same as saying x to the power of 5 upon 3. So we want the x's on the top line, so that's going to be the same as writing 2 upon 3 x to the minus a half. And the second one is going to be the same as writing 5 times x to the minus 5 upon 3. So now we can do the differentiation. So we can say that f derivative of x is going to equal, well, we multiply by the index, so we're going to have minus a half times the 2 upon 3 x to the power of 1 less than this, which is going to be minus 3 upon 2. And the second part of it is going to be the minus times the minus will give you a plus. And we'll be multiplying by 5 upon 3 times the original 5 here times x to the power of, well, 1 less than minus 5 upon 3 would be minus 8 upon 3. So in effect this line here is, that's us done our differentiation, but we'll just rewrite it in a format that's a bit neater. So f derivative of x is going to equal, we'll multiply these out, so we're going to have minus 2 upon 6, that's x to the minus 3 upon 2. And this is going to give us 5 times 5 is 25. So it's going to be 25 upon 3 x to the minus 8 upon 3. So therefore we can rewrite this as f derivative of x is going to equal, well, minus 2 upon 6 is the same as minus 1 upon 3. Now we can take this down and it will become x to the 3 upon 2. And this one's going to be plus 25 upon 3 times, we can take the x down, it becomes x to the 8 upon 3. So finally we can rewrite this in the form minus 1 upon 3 times the cubed root, the square root of x cubed. And this one here can be written as plus 25 upon 3 times, now it's going to be the root of, and it'll be the cubed root of x to the power of 8. So that's the final answer here. And as you can see that there's only really one line there that's done the differentiation, and that's going from this line here to this line here. And all the rest of it is just messing about to get it into the correct format. So let's look at another one. So let's look at differentiating the function f of x is equal to 2 sin x plus 3 cos x plus 2 upon root x. So how do we differentiate the sine and the cosine? Of course you can just memorise these, but let's say you couldn't remember, then you can derive them for yourself. You could sit down and you could draw out, let's say for example we take the first one and we draw out the sine function. You know the sine function looks like this. And we're looking to find out how we differentiate it. So let's say we take it that point 0. You can see that the rate of change here is going to be positive. So when we differentiate, all we find is the rate of change. So we know at 0 that point is going to be this value here. And we can see that as the rate of change, as we work along here, the rate of change decreases until it gets to a point 0. So we know it's going to come down like this. And when it comes down like this, this is the cosine function. So when we differentiate sine, we're going to get cosine. So we can say that f derivative of x is going to equal 2 cos x. Now we can do the same for the cosine function. If we were to draw it out, and you see the cosine function looks like this. So when we differentiate the cosine function at 0, well, the rate of change at 0 is just 0. Okay, it's a turning point, so the rate of change is 0. And then as we work along here, you can see that the rate of change is actually a negative value. It goes down this way. So it must be coming down like this. So if it comes down like this, what we're going to end up with is the negative of the sine. So the sine looks like this, so this is the negative of the sine. So we're going to have minus 3 sin x. Now 2 upon root x, that's the same as writing 2 x to the power of minus a half. So therefore we can multiply by minus a half, so that's going to be minus here, we'll get a minus sign, and we're going to have the minus a half, so the 2 from the half will cancel with the 2, and we're just going to have x to the power, and we take 1 less than minus a half, which is going to be minus 3 upon 2. So we can rewrite this out as f derivative of x is going to equal 2 cos x minus 3 sin x minus, well, if to the power of minus 3 upon 2 is the same as 1 upon x to the 3 upon 2. So finally we could say that f derivative of x is going to equal 2 cos x minus 3 sin x minus 1 upon, now it's going to be the square root of x cubed. So that's it there. So I've talked through a bit more detail than you would normally, because if you were say getting an exam, you would know that when you differentiate sine you're going to get cos, and when you differentiate cos you'll get minus sine. But if you can't remember it, you should be able to derive it just from drawing out your graphs and thinking about how the graphs change and what the rate of change looks like. So thank you for listening. I'll get you on the next video. Goodbye.